Okay, so now we're back to here. Okay, yeah, so we just talked about the power rule and could be all real numbers. We'll see very soon that, yes, indeed, and could be all real numbers. Okay, and then the third rule in section 3.1 is if we have a constant multiple rule. That means if we have a function f of x, which is a differentiable function, c is a constant. So the derivative of this constant c times by this function f of x, okay, c times f of x, can be written by what? The derivative of f times by what? This constant c. That means we could move this c in front of the entire derivative. Okay, so this is a constant multiple rule. Okay. Alright, so what is a sum rule? Okay, sum rule means if we have, okay, both f and g are differentiable, and then the derivative of the sum can be written by the sum of the two derivatives. Okay, that's a sum rule. Difference rule is telling us, okay, f and g are differentiable, the derivative of a difference can be written by the difference of the derivative. Okay, the last one is for natural exponential function. The derivative of e to the x is e to the x itself. Okay, so these are the ideas, okay, the basic concept from section 3.1. That's it. Okay, yeah, that's it. Okay, for section 3.1, it's not too much. Okay, so you know this and this and then these rules. Okay, so now we're going to use this knowledge we just learned to do the derivatives. Okay, differentiation. Okay, derivative questions. Okay, so let's look at question 1, 2, and 3. A, B, and C. So question A, f of x equals 150.5, which is constant. What is the derivative of it? 0? Everybody go with 0? Yes. F prime of x equals what? 0, because it's a constant. Question B, r of t equals 5 times t to the negative 3 over 5. Which rule should we use? You learn all of these rules from the top. Which rule should we use?
Constant multiple difference.
Yeah, constant multiple rule, and also what? Power rule. Okay, so we're going to write like this. Okay, the derivative of function r equals what? It's a derivative of this, right? So it's the same thing as what? 5 times the derivative of t to the negative 3 over 5. Okay, I use a prime, means what? Computing the derivative. Okay, so a constant 5 times this thing. Okay, the derivative is 5 times the derivative of this part. Okay, so t to the negative 3 over 5 is derivative. Which rule should we use right now? The power rule. Okay, what does the power rule tell us? If we have x to the nth power, right? Well, in this question, what is n? Negative 3 over 5, right? So n...
Negative 3 over 5?
Yeah, 3 over 5. See? 3 over 5, right? So the derivative of x to the nth power will be written by n times. I'm still going to write as a 5. Okay, I copied it from here. Okay? Then times by n. What is n? Negative 3 over 5 times by what? T is our independent variable. Okay, well, it's the same thing. It is x here. Okay, to the what? N minus 1's power. What is n minus 1? Negative 3 over 5 minus 1, right? Yes? Yes, like this, right? Okay, so now let's simplify. 5 times negative 3 over 5. Negative 3, right? And then this is going to be t to the what? What's negative 3 over 5 minus 1? Negative what? 8 over 5, right? Done. Okay? Yeah. Some of you guys prefer to rewrite it because this result has a negative exponent. Do you know how to rewrite this answer into a result with no negative exponent? Yes, so it's going to be negative 3, I'm going to write it here, negative 3 times by what? 1 over t to the what? 8 over 5, okay? So that's going to be what? Negative 3 over what? T to the 8 over 5, okay? And some of the questions may ask you, can you rewrite this answer with a radical expression? Yes, can we? Yes. It is going to be negative 3 divided by what? Fifth root of what? T to the what? Is power. Or negative 3 over fifth root of what? T to the 8th power. Either way, okay? So we can put, the 8th power outside of the fifth root of t, or we can do a t to the 8th power and then fifth root. Either way, okay? So if the question is asking you, no negative exponent, no fractions for the exponent, they want you to describe it into a radical expression, then you can improve this, okay? But for me, I think this is already good. This is already okay, okay? In your exam, if the question does not ask you to rewrite your answer, if you give me this, you're okay, okay? But I'm just, I don't know whether the web assignment require you to rewrite your answer, type your answer in certain ways, okay? So this is question B. Any questions from question B? No? Alright, so question C. Complete derivative of h. If h is defined by x minus 2 times by 2x plus 3. So how can we do this problem? Follow that out. Yes, follow that out. X times 2x, 2x squared. X times 3, 3x. Negative 2 times 2x. Negative 2 times by 3, minus 6. So eventually, h of x equals 2x squared plus 3. Oh, like term, right? So give us what? Negative x minus 6, right? Okay, so the derivative of this function, which is h prime of x, should equals what? The derivative of 2 times x squared, right? So 2 is a 2, right? We copy this 2. X squared derivative. 2 times x. Minus, what is the derivative of x? 1. And then what is the derivative of constant negative 6? 0. Okay. Or you can still write a plus 0. So simplify 2 times 2x for x minus 1. Got it? Everybody? Question D. I want you to try this one by yourself. Okay, I'll give you a couple minutes after we are, doing the rest. Okay. So the suggestion is FOIL this out and then do exactly the same as we did for question C, right? So FOIL it out and then do derivatives. Okay. Question E. Y equals 3 times e to the x plus 4 over cube root of x. Compute the derivative of this function. For e to the x, we know the derivative is e to the x, right? But how can we differentiate this 4 over cube root of x? So far we only know power rule, right? So, can we rewrite the cube root?
Rewrite it as a power.
Yes. Rewrite this part as a power. How? 3 e to the x plus, okay, so 4 over, what is the cube root of x in the exponential form? Actually 1/3, right? Actually 1/3 is the same thing as cube root of x, right? Then this x is on the bottom. We cannot use the power rule directly, so we have to rewrite this term as equals 3 e to the x plus what? 4 times by what? X to the, what's 1 over x to the 1/3? 1 over x to the 1/3 equals x to the negative 1/3, right? Okay, so now we have natural exponential, we have the power, right? Power function. So the derivative of the function, we use y prime, is going to be what? 3 times, what's the derivative of e to the x? E to the x. Then the derivative for this part is going to be, well, of course we're not copy the 4 times by, what is n in this question? Negative 1/3, right? Times by x to the n minus 1. Negative 1/3 minus 1. You guys agree with me? Everyone? Okay, so let's simplify, okay? Let's simplify. So we should have 3 e to the x, 4 times negative 1/3, negative 4/3, right? Times by x to the what? Negative what? 4/3. Done. Everybody? So far so good? The last question, I will give you a hint. You can also try the questions, okay, by yourself. Differentiate y equals x squared plus 4x plus 3 divided by square root of x. So far we learned what? Constant function, derivative is 0, power function, also we know those sum rule, difference rule, constant multiple rule to differentiate this thing. Suggestion?
First thing is good to know, we'll get the x in the denominator out of the radical.
Yes! Square root of x. Okay, we're going to rewrite this thing. Hopefully you can split it into what? Sum of power functions. Okay, so first we're going to rewrite the denominator square root of x by what? X to the 1/2 power. Then what? Yeah, we have 3 terms on the top divided by 1 denominator, right? Can we split this entire fraction into 3 fractions? Okay, so we get x squared divided by what? X to the 1/2 plus 4x divided by what? X to the 1/2 plus 3 divided by what? X to the 1/2. Why we want to do this? Because we want to make sure that we have power functions for each of these 3 terms. Okay, so x squared over x to the 1/2. Do you know how to do the exponential rule? Keep the same base x, do subtractions, right? So 2 minus 1/2 is what? 3/2 plus 4 times by, this is x to the first power divided by x to the 1/2. Keep x, 1 minus 1/2, and 3 times by 1 over, which give us negative 1/2. You guys, everybody? Now each term is what? A power function. So to compute the derivative, what do we do?
Well, I have one question. When you multiply 4 times x to the 1/2, how come it's not negative 1/2 because you're dividing by it?
Because this 1 minus 1/2 give us what? Positive 1/2.
Okay.
This one is what? This is I'm going to rewrite this one, okay? This is actually 3 times 1 over x to the 1/2. It's not x.
Right.
So one we can consider this is x to the 0's power, right?
Yeah.
So when we keep the base x, 0 minus 1/2 is negative 1/2. This one, you understand, right?
Yeah, I understand.
This one is not 1, this is x. So that's why 1 minus 1/2 give us 1/2. This one is a constant 3, there's no x here. So we consider this is x to the 0's power is 1, right? So 0 minus 1/2 give us negative 1/2. You're welcome. Okay, so I want you to finish the question F by yourself. Later, I'll let you tell me your answer, okay? So, do question D, I'll give you a couple minutes, try this one, okay? Later, I'll ask you to do this, okay? And then also finish the question F, okay? I'm going to ask volunteer to tell us how to do question D. Who want to volunteer? Tell us. You tell me and I'll write down your answer. Anyone? Grant, you ready? Or no?
I'm having kind of a difficult day. Could you get someone else?
Okay. So, Brittany?
Okay, so you want to FOIL it out and then get 9a squared plus 6a plus 1.
Mm-hmm.
And then you do the power rule.
Okay.
And then you take the exponent 2 multiplied by the constant. And then you subtract 1. And then
Oh. Okay.
And then you get 6 as a constant.
Okay. So if we simplify, it's 18a plus 6, right? Who got the same answer? Please hands up. Okay, thanks, okay. So the rest of you guys who does not have the same answer, do you know how right now? Okay. So for you that will get us this, when we differentiate that, this 9a squared give us the 18a, because 9 is 9, a squared derivative is 2a, so that's 18a. 6 is 6, right? Derivative of a is 1, so 6 times 1 is 6. Constant 1, derivative is 1, 0. So that's 18a plus 6. Everybody? Alright, so question F. You are Mark, right?
Yeah, I just have a question about D here.
Okay, D.
So I know you get 18a plus 6,
Mhm.
and then you can simplify that to 3a plus 1. Is there any significance to the fact that that's the same as what you're squaring?
You factor out the 6, right? You get 6 times 3a plus 1, right?
Yeah.
That's fine.
So, but is there any significance to the fact that that's what the original equation is b squared? Like, see how it's 3a plus 1 squared? Is there like a relationship there?
Well, the answer is 6 times by 3a plus 1. Okay? Let's see. 6. This is 3a plus 1. You're asking because this is 3a plus 1 square.
Yeah, I did.
Okay? So, yes. So far in this section 3.1, we can only do it like this because we haven't learned any other rules like product rule, chain rule, okay? So once we learn section 3.5 about using chain rule, you will see we don't have to follow. We just need to do 2 times by 3a plus 1, and then we differentiate 3a plus 1 give us another 3. So 2 times 3 give us a 6. So yes, okay, yes. We can use a different method, but not now. You are kind of, ahead. You're ahead of us, okay? Ahead of us. Okay, so that's a good question, okay? So far this is how we do the question, okay? Either this or, well, you don't have to follow, okay? Yeah, well, you don't have to factor, okay? Just 18a plus 6, okay? All right, question F. I'm going to ask some of you guys, tell us your answer, okay? So these are basically power terms, right? Yeah. Power terms. Anyone tell me your right triangle result? Simon? Or
I did.
you did?
I'm not sure if I got the right answer. I got
Okay.
3 over 2x to the 1/2 power plus 2x to the negative 1/2 power minus 1.5x to the negative 3 over 2 power.
So what do you have here? Is it plus or minus?
Minus
Minus 3 over 2 x to the what? Negative what?
negative 3 over 2 power.
Check. Does everybody agree with Simon? Yeah, x to the nth power, yes, it's correct. Okay, this is the correct answer. Good for you, okay, yeah. So x to the 3/2, okay, so this is n, okay. So what we do is, derivative equals n times by n minus 1's power, right? So 3/2 minus 1 give us 1/2, so that's right. And then 4 times by x to the nth power, n move it in front, 4 times 1/2 give us 2, and then 1/2 minus 1 give us negative 1/2, you're right. This one is 3 times by negative 1/2, which is negative 3/2, times by what? Negative 1/2 minus 1 is negative 3 over 2. So right, correct. Tyler? Agree with this? Nick? Terry? Everybody? Okay. Alright, so this is section 3.1, okay? We don't, actually there are not too much materials from section 3.1, okay? So you basically understand all of this, okay? If you understand all of this, and then what you're going to do is just practice to make sure that you're more familiar and more ready to do the derivatives, okay?